So today we're looking at a set of pistons and cylinders that were sent to us by a customer that's doing his own engine. And our job today is just to measure all of the pistons and cylinders and give him an idea as to whether or not they are usable. So I've got them lined up, cylinders are matched, pistons were marked by the owner and cylinders were marked. So I've got everything staged out. And just kind of wanted to go through what we look at for a set of pistons and cylinders. There's going to be a number stamped on this cylinder. This one is a number 2. I refer that to my shop manual or my little handbook, and a standard piston would be marked as 0. And then 1, 2, 3 are the other tolerance groups that pistons are fitted to barrels when they're new. So a new fitting on this particular piston would have been 94.979 to 94.89 millimeters. So that gives me a baseline of where this cylinder started out in life, and I can tell how much wear it has. My measuring points on cylinders are going to be on the skirt. And if we look right here, this groove here is about the measuring point that we want to do, and I'm using my micrometer to actually measure that. And it's using it almost like a feeler gauge, and it's a combination of winding the thimble in and getting that nice tension, but the piston has to be able to roll through because we're measuring on a circle, so it's not a dead flat surface when you're measuring against. So after comparing and measuring all of the pistons, basically what we have is everything is at least 0.04 of a millimeter smaller than its new design. So that's kind of one factor that we're looking at. So the next thing that I'm going to look at as to whether or not a piston is usable or not is going to be the ring lands. When piston rings are fitted, what happens is the rings will actually flutter back and forth. So as the piston goes up in the cylinder, the ring's being drug up. As it comes back down, that ring moves. And this ring land will actually wear. So what I'm doing is I'm taking a piston ring and I am using my feeler gauge to go in and measure what the clearance between the ring is and the ring lands, and then record what that number is, and I have that spec into the book. The other thing I'm looking about, a quick test, is how much movement up and down. So that's the top ring, then second ring, and we can see just on the amount of movement, the wear on the second ring groove is about half that of the first ring groove. And then lastly, the oil ring. Same thing, we're going to slip this in, and the oil ring on this piston is nice and tight again. So what I found on all of the pistons is a sizable amount of wear in the ring lands, particularly in the top ring lands, but none of them hit the wear limit of 0.2 of a millimeter of wear. So technically, looking at the ring lands, the pistons are still usable, although the wear is significant. The next area I want to look at is where the wrist pin slides in. And this piston, normally I have wrist pins with it that I can measure and see what they look like wear-wise. This customer did not supply wrist pins, so I can only really do a visual, as once they've run with it, they're kind of matched with it. So I'm just usually running my fingers around in here and seeing if I can feel any signs of scoring or lipping. Usually if I look in there, I can see some signs of wear. It's probably hard to see on the camera side of things, but right in here we can see where the bottom side's maybe got a little bit more wear than the top side. But on the whole, doesn't look really bad there. I'm hesitant to kind of pin fit these without a piston pin present, just so I can measure, as there is tolerances on these as well. The last thing that I'm looking at is the general appearance of the piston and what kind of condition is it in. Now this particular one has had some debris here and here. These can be kind of somewhat polished out. You don't want to have any particular sharp edges that could attract carbon buildup. The bottom side of the piston has also looked like it's seen some kind of failure here. Could have been a punch put across here to maybe undo a crank bolt. That I'm not sure about. But pretty much all of these pistons have seen a pretty rough life. Just signs of damage. This one's also had some marks placed in it here. These are not usually running damage. This has to be external. So not really sure what was happening with that. This one looks a little better. But all in all, certainly have seen better days. Okay, next thing I'm going to look at is the cylinders, and pistons that have run in a cylinder are now matched to it. So a couple of things that I'm looking for. First thing that I'm looking for is any kind of lipping at the top of the cylinder. And this will tend to lip. You can see the staining from where the rings stop. When the piston stops and the ring stops here, that ring flips over and it can tend to wear into that cylinder. This one's not feeling too bad, although one of the cylinders in the set I can definitely catch a thumbnail on. This one I can feel a slight lip, but it's not really bad at this point. So the next thing I want to do is I want to measure wear, taper, and ovality, and I can do that all at once. So I've got my bore gauge and I've calibrated it to 95 millimeters so I can measure my wear. But what I want to do is at the bottom of each cylinder, I want to take a measurement. And then I want to take a measurement this direction as well. And what this is telling me is the cylinder still round around this circumference, or am I getting a different reading over here? I then want to do that reading again with my bore gauge almost all the way in, and I want to compare that reading. And same once again, I'm going to do it at 90 degrees and take that reading. What these numbers are going to tell us is wear in the cylinder, ovality in the cylinder, and taper in the cylinder. So taper, typically a piston and cylinder set will wear more at the top than at the bottom. And so Porsche gives us specific specifications for this. And what I've done is I've gone through and I've recorded the wear in each cylinder. So for example, we're looking at cylinder number 1. The wear in this cylinder is 0.036 of a millimeter, and the ovality I came up with was 0.024 of a millimeter, sorry. Cylinder 3, I've got 0.040 in ovality, and I measured that right at the top of the cylinder. That is the maximum spec that Porsche will allow a cylinder to continue to be operated. Then where I've made these different marks next to a cylinder means, if I've got my little hash mark there, it means cylinder number 2. We had a much larger wear than cylinder 1. And I also had a very discernible ring lip at the top. So if I grab cylinder number 2, I can visually see the wear is greater in that cylinder. And then when I run my fingers around, right here, I can definitely feel that ring lip quite easily. I can catch it with my fingernail. So that is something that I would fail that cylinder on, even though technically it's within the wear limits. The last thing that I had is cylinder number 3. Has a wear of 0.045 millimeter. This is our one that has ovality. This cylinder exhibited a little bit more excessive scoring, and it had some weird surface marks in there, which I can only really see with my flashlight. Oh, there it is, right there. So in cylinder number 3, I had some weird marks, like something went through that cylinder at some point. and I can feel them in that cylinder ball. Okay, the last thing that I want to do is measure the piston to cylinder clearance. And to do that, I'll usually do it in a couple of different places. So I'll take the matching piston, and usually I'll start it up fairly high, which is usually fairly minimal wear. And what I'm going to do is take my feeler gauges and slide them in and measure that clearance. Now, Porsche tells us that if we get to 0.15 of a millimeter piston to cylinder clearance, then the pistons and cylinder set is no longer serviceable. On these, I had a varying amount of measurement. I usually like to measure them at top and bottom. As you would expect on the top, the clearance gauge I'm using right now is 3 thousandths, which is 0.076 of a millimeter. Easily goes in and out. New clearance is 0.02 to 0.045 of a millimeter. So we're over 50% of the way worn. And I'll usually check that in a couple of different spots on the cylinder as it moves up and down, just to get my largest clearance and see if the piston, how much the piston is going to rattle in that cylinder. So basically, my assessment on this particular piston and cylinder set is that it is over 50% worn. So to me, I would not install it in an engine that I would expect to go another 100,000 plus miles. The wear in the barrels, particularly cylinder 3 barrel, I wouldn't even put that one back in no matter what, with the wear and the lipping that it's got. Barrels 2, 5, and 6 are also showing more of a lip at the top than the rest. The pistons, though, the clearance between the piston and cylinder still being within the maximum limit that Porsche gives us, would still give for a noisy operation. These are just not going to give the life that you are looking for in a new engine. If you're spending a lot of money on cranks and rods, making sure everything is being restored back to its initial running clearances, it just doesn't make sense to put a set of pistons and cylinders that are over 50% worn back into an engine.